Welcome to my channel, Maths with Macbull.
Hello, assalamu alaikum to all viewers and dear students. Today we have a new question number 3.5 exercise, question number 4, differentiate the following function, and question number part B is equal to part B. Y is equal to cos hyperbolic 3x. Derivative of the cos hyperbolic is x. Cos hyperbolic is equal to sin hyperbolic x according to. Now we are differentiating on both sides of this equation dy by dx cos hyperbolic 3x. Now according to the derivative of, so we write here the derivative of cos hyperbolic x is equal to sin hyperbolic x according to this formula, and further we are taking this derivative of x. But here in the place of x, here we put 3x. So now we are using this formula. According to this formula, we can write sin hyperbolic 3x and derivative of x, and derivative of further x, we are taking derivative of 3x. So is equal to sin hyperbolic 3x, and to derivative of x is equal to 1 multiplied by 3, we get 3. So the final result 3 sin hyperbolic 3x, and this 3 is bring here to the coefficient of sin, that is the answer of y is equal to cos hyperbolic 3x. See, y is equal to sin inverse hyperbolic cos x. Inverse x, sin hyperbolic inverse x, sin hyperbolic inverse cos of x. So how we calculate? We are differentiating with respect to x. Now we are differentiating with respect to x on both sides of this equation. We write here dy by dx is equal to dy by dx sin hyperbolic inverse cos of x. So according to this formula, sin hyperbolic inverse x is, we can write the formula 1 plus x square under the root, and further derivative of x is equal to 1. According to this formula, we can write this here in the place of x, here is cos of x. So we put 1 divided by 1 plus cos square x under the root, and further derivative of cos of x, because here in the place of x is cos of x is used. So now 1 divided by 1 plus cos square x under the root, and derivative of cos x is minus sin x. Now minus sin x is multiplied by 1, so we get minus sin x divided by 1 plus cos square x under the root. So this is the answer for the question of y is equal to sin hyperbolic inverse cos of x. Y is equal to tangent hyperbolic inverse x by 2. So now again we are using the same method. We are differentiating with respect to x, dy by dx is equal to dy by tangent inverse hyperbolic inverse x by 2. According to the formula, first of all we write the formula dy by d tangent hyperbolic inverse x is equal to 1 divided by 1 minus x square and further derivative of x. So according to this formula, if we are applying here dy by dx, tangent inverse 1 divided by 1 minus in the place of x by 2 and further derivative of x by 2. Now we can expand this result 1 minus, we can write x square divided by 4 and derivative of x is equal to 1, x derivative is 1 and 1 divided by 2. 1 by 2 is constant, it is outside from the variable, so we take the derivative of x is 1 by 2. Now we are taking of this LCM of this one, we write that LCM 4 minus x square divided by 2 and 2 1 over 2. This 2 are cancelled because this is the reciprocal of 2. We can write 4 minus, and here is 4 is the LCM. 4 is the LCM. 4 is the LCM. And 4 multiplied by 1. 4 minus x square 4. And 4 is the reciprocal of this one. 4 divided by 4 minus x square into 1 over 2. 2 and this is cancelled. We get here 2 divided by 4 minus x square is the answer of this question. y is equal to log of cotangent hyperbolic x. Now we are differentiating the same method we are using here. We are differentiating with respect to x, dy by dx log of cotangent hyperbolic x. According to this formula dy by dx, we are using log of x is equal to 1 over x and further derivative of x is equal to 1 is equal to 1 over x. According to this formula we are using here. So 1 over x and this is considered x. 1 over x, so cotangent hyperbolic x and further derivative of cotangent hyperbolic x. 1 divided by cotangent hyperbolic x, and cotangent hyperbolic derivative is equal to minus cosecant square hyperbolic square x. The derivative of cosecant hyperbolic square x is, we can write according to this formula, cosecant hyperbolic square x plus cotangent hyperbolic square x is equal to 1. But here we are needed this result, so we can write cosecant hyperbolic square x is equal to, this will be changed to the right side, 1 minus cotangent hyperbolic square x. Minus, in the place of this result we put here 1 minus cotangent hyperbolic square x divided by cotangent hyperbolic x. If we multiply this one, we can also multiply minus 1 plus cotangent hyperbolic square x. We can write this term divided by cotangent hyperbolic x. That is, the answer is equal to cos x cos hyperbolic inverse x minus x square minus 1 under the root. Question number 4 to x. We are differentiating with respect to x on both sides of this equation. So we can find dy by dx, and replace of x, here we put x cos hyperbolic inverse x minus x square minus 1 under the root. Here we are apply this derivative individually because there are two terms. Here we can write dy by dx, dy by dx, x cos hyperbolic inverse x minus and derivative of x square minus 1. Here we are using the product rule, multiplication rule. We are using here x derivative of cos hyperbolic inverse x plus cos hyperbolic inverse x derivative of x according to the product rule minus, and this rule we can write here this point we can write dy by dx x square minus 1 square root we can write 1 by 2. Here according to the power rule 1 by 2 x square minus 1 and 1 by 2 minus 1, and further derivative of this function dy by dx x square minus 1. Now x derivative of cos hyperbolic inverse x is equal to 1 divided by x square minus 1, and further derivative of x is equal to 1 plus cos hyperbolic inverse x, and x derivative is 1 minus 1 by 2 x square minus 1 and minus 1 by 2 and root 2x. 2 and 2 are cancelled. So we can write this result x divided by x square minus 1 under the root plus cos hyperbolic inverse x minus x multiplied by 1x, and this will be changed into the denominator x square minus 1, and also we can write this result 1 by 2. So both are, one is positive, one is negative, both are cancelled. So we get the result cos hyperbolic inverse x. That is the answer of this question. Thank you very much for watching. Please subscribe my channel and share this video with your friends. Thanks again for watching.